example of a vector. This is from the May 2019 CSEC Mathematics paper, question 10b. Relative to the origin O. What that means is you have your x and y axis. This is your y axis, and this is your x axis. Relative to the origin, both vectors start at the origin, meaning they are position vectors. Position vectors usually start at the origin. So, relative to the origin O, that is the origin, 0, 0. The position vectors of the points A and B, right here, are OA, 0, is 9, 0. You can see here, you move 9 units to the right in the horizontal, but 0 in the vertical. You need a move up nor down. Remember, this here is generally written in the form x, y. That is a column matrix. X, remember, x tells you whether you are moving left or right. You're positive to the right, negative to the left. Y tells you whether you move up or down from the origin. Upwards is positive, downwards is negative. Remember those things. Now, here, what you have is the other vector OB. OB is this vector going from O to B. It is 3, 6. What that means, you can move from O to B right along the vector, but you could have moved, remember, it's 3, 6, meaning x, y. Positive 3 means you move 3 places to the right. You could have moved 3 places to the right, turn the corner, then move 6 places upwards. Positive 6. You would end up the same place right here. You see that? Now, the point D, this is D, and E, this is E. You see D and E. Are on AB. They are lying, D is lying on AB. This is AB, the vector AB, and D is lying on it. So you see that. And E is on OA. O to A, that is OA. Ensure you see that. Now, here, such that AD from A to D is 1/3 all the way from A to B. What that means, if all of this distance is 3, then from here to here is 1. See that? This is here, this is only 1. And remember, all of this is 2. So you have 1 here and 1 here, making 1, 2, 3. That is what this is saying. OE, from O to E, right here, is 1/3 from distance from O to A. You see that? So OE is 1/3 OA. AD is 1/3 AB. This is 1, but here this is 2, which you can break up into 1 and 1. We will look back at it later. Now, your question here says, express the following vector in the form AB. Now, where are the vectors? Let us see. I had copied this over to the other screen. So here we have AB. We need to express AB in that form. What is AB? From A to B. If we go from A to B, we're going from 90 to 36. Now, what we could say here, since AB would be the resultant of 2 other vectors. We have A here and B here. It is the same diagram I'm copying. You go from A to O. Remember, O to A is 90. But if this is the resultant cannot follow any other arrow around the triangle. So you must turn this triangle around, so that when you walk this way, turn the corner and walk this way, when you should turn this corner and continue walking, you will be opposed by these 2 arrows on the resultant. The resultant is AB because that is what you want. What you will do is say, if you walk from A to B, you end up right here. However, you could end up the same place by walking A to O, turn the corner, then walk O to B. You see that? So therefore you can say AB is equal to AO plus OB. A to B, you end up the same place by saying A to O, then O to B. Do you see that? You get AB by adding AO to OB. That is what you have there. Now, AB is AO. OA, as you saw here, OA is 90. So AO must be the negative of that. Remember, this is resultant, so I have two arrows here. It's AO from A to O plus O to B. See that? So, since AB is AO plus OB, you can say AB equals. Remember, they want you to have it in the form of AB, in this form, a vector matrix. Now, what you have is AO. Remember, you had OA as 90. So AO is the inverse vector. It must be -9. I was tempted to write -0, but whether it's negative or positive doesn't make a difference, so I write 0 plus OB. What is OB? OB is 3,6. It remains as is. 3,6. Do you see that? Now, what this is saying, you add the x's together to get the new vector. -9 plus 3. 0 plus 6. Then, here, this will give you the same thing as -9 plus 3 is -6. 0 plus 6 is 6. So, what this is saying is that you could move from A to B by moving 6 units to the left, then 1 unit, then 6 units up, and you end up right at B. So therefore, the answer is AB, vector AB equals -6, 6. You see that? Now, the next part of the question. OD. I'm going to erase some of the working here. We know that AB is -6, 6. Let me make a note of it up here. AB equals -6, 6. See that? Now, what we want is the other part of the question, OD. So let us find out what OD is. We want OD. here, OD is this vector. So our vector now looks like this, and it is a resultant. What two vectors do you add to get OD? Remember now, OD goes from here to here. That is OD. You could end up at D starting from O by going this way, then turning and going this way. Therefore, OD is equal to OA. Remember, here. OD, going from here to here, is equal to OA, going from here to here. Then going from A to D, so you say plus AD. Do you see that? Now, OD, which we want, is equal to OA. What was OA again? OA is 90. OA is 90 plus AD. But AD is 1/3 of AB. AD is 1/3 of AB. So you plus 1/3 of AB. Do you know AB? Yes. We found it earlier. It is -6, 6. Now, OD is equal to 90 plus 1/3 of -6, 6. Do you see that? Now, the next part of the question where we want to reach is OD equals 90 plus, we must multiply -6 by 1/3. We will find 1/3 of -6. What is 1/3 of -6? It's -2. So this is -2, and 1/3 of 6 is 2. Remember, the 1/3 must multiply this number as well as this number. Alright? So, OD is equal to, this is 90 plus -2, 2. So here, OD is equal to 9 plus -2 is 9 minus 2, which is 7. 0 plus 2 is 2. So OD is 7, 2. Let me make a note of it up here. OD is equal to 7, 2. So you see that. Good. Now, 7, 2. Next, will find BE. That's BE. Are you ready for BE? BE is next. We erase, then go to BE. Here, we're going to be finding BE. Where is BE? BE is this vector. Let's erase what we have here. Then highlight BE. We're going from B to E. This is the vector we want to find. What do we do? Going from B to E. We say here, when we go from B to E, we could end up the same place, going from B to O, then O to E. You see that? So, what we say here is that BE, which is going along this vector, is equal to BO, which is going along this vector, plus OE, which is going along this vector. So, what is BO? We need BO right now. We see that OB is 3,6. So BO must be negative 3,6. OB is 3,6. So BO must be negative 3,6 plus OE. From O to E is 1/3 OA. Remember that. OE is 1/3 OA. So we say plus 1/3 OA. You see that? But what was OA again? OA was 90. So BE is equal to BO. We can have the negative multiply each term inside the brackets. It's like -1 multiply everything. So it's -3, -6 plus 1/3 OA. And OA is what again? It's 90. So it's 1/3 of 90. So what we have here is -3, -6 plus 1/3 of 9 is 3. 1/3 of 0 is 0. Do you see that? So, we have -3 plus 3 negative 6 plus 0. Negative 3 plus 3 is 0. Negative 6 plus 0 is negative 6. What this is suggesting is that BE, to go from B to E, you neither shift left nor right along X, but you go 6 units down along Y. You don't move left nor right, but vertically you move straight down 6 units. You can see it here. From B to E is straight down, and it is 6 units down. That is what it is saying. So do you see that? So that was part B of question 10, the last question of the paper, of the May 2019 paper.